Okay, so this is the main topic for today's webinar. How do we calculate floating rate under SOFR? Okay, once you grasp this particular topic, everything else will be easy. I get a lot of questions like the different term structure models that we had, right? Short rate models, market models, and ways of constructing the yield curve, binomial tree, or even analytical solutions. Are those still valid? They are still valid, yes. But from a pricing perspective, you have to adjust the valuation a little bit. So that is what we're gonna talk about. Okay. All right. Don't get intimidated by this particular slide. I'll walk you through this particular topic. So let's proceed slowly. Okay. On the left hand side, I have the LIBOR system. On the right hand side, we have SOFR system. So consider a 3-month LIBOR rate. Okay. 3-month LIBOR rate. And what the use case that we are looking at here is how do we determine a floating coupon rate for 3 months, right? So you need a floating rate as part of, let's say, a floating rate loan, floating rate note, or maybe let's say interest rate swap, plain vanilla fixed floating interest rate swap. You need to calculate the floating rate from time to time. On each reset date, you have to calculate the floating rate, correct? In LIBOR days, it was based on the LIBOR rate. So LIBOR 3-month rate. But the main difference is, um, in case of LIBOR, we also had a fixing lag of 2 business days. Okay. That means the rate that is applicable between the start date and end date, which is 3 months apart, was already available 2 business days prior. LIBOR fixing date. Okay. The 3-month rate was already available 2 business days before. So, but the biggest point here is it is forward looking. That means you already know the rate that is applicable from S to T. Both of these are in future. These 2 time points are in future. I know the rate for a future period, right? The rate is fully known at S, not actually at S, even 2 days before. So here, if you look at this particular picture right below, the floating coupon rate is nothing but the notional times year fraction. Year fraction is 0.25 for 3 months, right? It could be little bit different based on the day count convention, right? Act by 360. Number of actual days might be different, but for convenience, I'm taking it as 0.25. Notional times 0.25 times this floating rate, correct? This floating rate is fully known at this point. You exactly know what is the floating payment that you're gonna get, right? So it is known in advance. Okay, so it was forward looking and it was known in advance. That is how we determine the floating coupon. Now come to the right hand side. SOFR. There is no concept of a SOFR term rate, like an outright SOFR term rate. Nobody quotes directly in terms of that, right? We have to infer in indirect ways. So the base quotation convention for SOFR is just an overnight rate. One tenor overnight. That's all you have. Okay. And you only know it the next day when it gets published. There is no forward looking nature in case of SOFR. It is whatever has happened in the repo market yesterday that gets known the next day. Okay. So when you are here, again, it's the same kind of contract, 3-month floating rate coupon I need to calculate. On the start date, you actually know nothing. What would be the floating coupon payment? You know nothing about it. Okay. It's only after all these SOFR daily rates are published day by day, when all the daily rates that are part of this contract period are published, only at the end you would be able to compound all of these daily rates and come up with the final settlement, the floating interest payment that will be part of your settlement. There is no way to know this in advance. You can estimate, but it is subject to fluctuation. As and when you progress through time, some of these daily rates will be fixed because they have already happened. You cannot change it, right? So that is where we're leading into complications. But for now, understand that there is no way of knowing the floating rate payment in advance. Okay, it will get updated every day until you reach the final, the end of the contract period. Only then you would be able to compound all these daily rates and identify the actual floating rate coupon payment. Okay, so here you can see it is unknown in the beginning, but only when you reach here, then you know what is the rate that is applicable. I'll pause here. Let me know if any questions, because this is the main fundamental mindset change that you need uh, to uh, to do justice to SOFR based valuations. Is this understood? Any questions? Clear? Okay. All right, let's proceed then. So let's do some calculations. So there's a question from Gurpreet. How does this impact fixed rate for swaps? Fixed rates are fixed rates. There is nothing, no impact on fixed rates. When you value a swap, obviously the fixed rate has to be calculated in such a way that the value of swap is zero at inception. But if the swap has not started yet, right, then everything is based on your yield curve. The floating rate. So let me actually walk you through a little bit of more on this topic, and then you'll be able to understand. So from a settlement perspective, as we discussed, right, how do we calculate the floating coupon? I said that we have to compound the daily published SOFR rates and then calculate the floating rate that way. Okay. So this is a simple example. I'll show you the actual working example in Excel. So understand this. So let's say we're trying to calculate the total interest payment over 1 week. Okay. So here you can see the days. Now, the SOFR rate that is applicable for Monday, R1, will be published on Tuesday. R2 is the SOFR rate that is applicable for day 2, which is Tuesday, but you will know it, or it will be published on Wednesday, 8 a.m. Eastern Time. Right? So this is the published date. And remember the last one, Friday. Friday rate is R5, but you will only know it on Monday. Okay. All right. So from a compounding perspective, so these are the rates. In order to calculate the entire weekly rate for 7 days, what is the total interest payment? Okay, you have to compound these rates. Okay, and you can only do that when Monday comes, because until you know R5, your story is incomplete. You need R5, right? Friday's rate you'll know only on Monday. So on Monday, when the Friday rate gets published, at that point you should be able to complete the story. Take all these 5 daily rates, do the compounding. Okay, and then you will know the final coupon payment that is due on Monday. It may be due instantly, but it may be also due after 2 days, depending on like if we introduce a payment lag for 2 days, then or settlement days T+2, then also you can. I mean that amount becomes fixed, but it will be paid after 2 days. Okay, but that's fine. We're talking about the calculation part, right? So look at this calculation. So it's actually very easy. For each working day or non-business day, the effective number of days for which the rate is applicable will be 1 day each. Correct? The Friday rate carries over for next 3 days, right? Friday, Saturday, and Sunday. So that's why the day count, the number of days for which R5 is effective is 3 days, not 1 day. Okay, now we compound. For compounding, it's easy. So 1 plus rate times the year fraction. Year fraction is number of days for which the rate is applicable divided by 360. So 1 plus R1 times D1 by 360. 1 plus R2 times D2 by 360. D1, D2, D3, everything is 1, is applicable for 1 day, except for Friday, which would be this D5, 1 plus R5 times D5 by 360. D5 would be 3 days. Okay, Friday rate will carry over. Now, sometimes you have public holidays, like let's say July 4th in US, we have the new year for US, July 4th. So if it's a long weekend, then sometimes the Friday rate or even Thursday rate will carry over for 4 days. Okay, so that you have to consider. Once you have got these growth factors, just multiply everything. You have the entire compounding factor. So this is this part. If you look at the formula on the top, it's just see 1 plus r times year fraction. Year fraction is d by 360. D is based on 1 or 3 depending on whether it's a business or non-business day. Multiply everything minus 1, right? That's the interest. This is compounding factor. Minus 1 will give you the interest value. Then annualize it. So this compounding is applicable for 7 days. Then what is the rate for 360 days? So you multiply 360 divided by 7. That gives you the final rate. Okay, let's look at the calculation in Excel. That will make things clear. Okay, so a lot goes on here, so pay attention. Wait. Do you guys need a break? We can continue after 5 minutes. I know it's been an hour. Let's do one thing. Let's take a 5 minutes break. We'll continue this. I'll need another 30 to 40 minutes. Okay, let's meet after 5 minutes. Okay, so let's look at some of the basic calculations. So what I did, let me actually zoom this so it'll be easier for you to see. I downloaded the published SOFR rates from the Federal Reserve Bank New York website, as I showed you, right? The first time they published the SOFR was on 3rd April 2018. Okay, it is for the date 2nd April. 2nd April transactions, right? The SOFR rate for this date was published on 3rd April. This particular day is a Monday, okay, and the rate was 1.8%. That is the first SOFR rate that was published back in 2018 April. All right, so the basic calculation of compounding. So there are two ways you can calculate an overall rate, right? It can be based on compounding, which is geometric mean, or it can be based on simple arithmetic average. Okay, compounding is popular. It makes more economic sense, but simple average is also used for one specific product, which is 1 month. So for future, we'll talk about that. Anyways, for now, let's focus on. Actually, you know what? Let's calculate both arithmetic average and the compounding or geometric average. Okay, so what I want to do is from this date to this date, right? I want to calculate the total compounding interest rate. So these are the daily published SOFR rates. Now, the days for which each of these rate is effective is based on whether it is a weekday or holiday, right? So you can see for Monday, the days is 1, Tuesday it is 1, 1, 1, 1, 1 each. For Friday, it is 3 days, as we discussed, right? If there is an additional holiday, so it becomes a long weekend, then Friday will get a weight of 4 instead of 3. But 3, normally it will be 3, right? So yeah, first step is to calculate the, let's say the year fraction. Year fraction is simply actual divided by 360. So D divided by 360 is your year fraction. For Friday, it will be different, 3 divided by 360. Then what I want to calculate is 1 plus R times D by 360 or R times tau. Tau is the year fraction. So that is what I'm doing. I'm doing R tau here, so which is basically R times the year fraction, and then add 1 to it, 1 plus R tau. These are the daily, CME calls it as DIAF, daily interest accumulation factor, which is kind of like for 1 day, what is the growth factor, right? 1 plus R times year fraction. Get all those, and then you multiply, do -1, annualize. These are the steps. So let's go through the steps here. So this is my accrual period of 1 week. Start day is 4/2, end date is 4/9, In between that, we have an entire week. So 7 days, calendar days. Let's do the geometric average first, then I'll talk about the arithmetic average. Geometric average, as we discussed, is very simple. Product of all these 1 plus r tau, just multiply them. That's the total growth factor over the entire week. Minus 1 gives you the interest amount. Then you annualize. So times 360 divided by 7. 7 is the number of days in that week. Okay, that gives me 1.7674% as the sort of like a term rate. Okay, for a week. So if you have a coupon that is a weekly coupon, just assume, making things simple, the coupon payment will be based on this rate, which you calculated at the end of the period. There is no way of knowing what will be the coupon payment for the week in advance. Only after the week is over, all the 5 rates have been published. Then you do the compounding and find out the floating rate payment, floating rate interest rate based on which the payment will happen. Make sense? Now, there is a shortcut to do this. But there are some caveats here and there, but I'll tell you the shortcut. The shortcut is, why are we compounding each and everything? Why not keep an index which keeps track of that growth factor, and then we'll simply do final index divided by the initial index. That will give us the total growth factor, right? That is the purpose of index. So at the very beginning, we set a notional index as 1. That means growth factor is 1, and then we'll start compounding it, right? So this calculation is basically, the new index is previous index multiplied by growth factor 1 plus r tau. That is what I'm doing recursively, right? Next index is previous index multiplied by the growth factor. If I can keep a track of the index, the beauty of this is, if I want to calculate the growth factor for a week, right, I can simply divide the final index divided by the initial index. That will give me the growth factor. Just a simple division. I don't have to multiply all of these daily growth factors one by one, right? So this is another calculation. You can see what I'm done here is final index, which includes this rate, divided by the initial index even before the week, whatever was the base index that to start with. Take that ratio here. That is the product of 1 plus r tau, basically. Minus 1 and then annualize. It will give you the same answer. Oops, sorry. Yeah. So this is geometric average. Okay, this is the main calculation that is used for settlement purpose. You can also calculate arithmetic average. Arithmetic average is even easier, right? You just do a simple average. 7 different rates, you do a simple average. The only thing is, we only have 5 rates, right? How do we calculate 7 different rates? Well, the Friday rate will continue. Okay, so we have 1, 2, 3, 4, 5. Then for Saturday and Sunday also, we continue that 1.75% and then take a grand average. Okay, so it'll be this plus this plus this plus this plus 3 times this divided by 7. That's the arithmetic average. Okay. All right. Right. So I hope you understood geometric average, arithmetic average. And then, so these are the basic SOFR rate, compounding and average calculation. On top of that, Federal Reserve Bank, New York, as I mentioned earlier, right, they started publishing the moving averages. 30-day moving average, 90-day moving average, 180-day moving average. These are also compounded using the same idea that we just discussed. They use geometric average. They don't use arithmetic average. And they started publishing these from the date, let me go down, I think 2020 sometime. Yeah, from here. From this date, they started publishing the 30-day, 90-day, and 180-day moving averages, which can be considered as proxy for term rates. Okay, remember when we talked about fallback, right? So if you want to calculate a 30 days or 1 month LIBOR. If you want to calculate 1 month LIBOR, LIBOR does not exist anymore. So what would you do? 30-day moving average plus the spread. That is 1 month LIBOR. Okay, it is one of the anchor points. The moving averages serve as one of the anchor points. So for some products where you can infer the LIBOR by adding the spread to these moving averages. Okay, and how is this moving average calculated? Again, 30 days formula, right? So for the last 30 days, from this date, you go back 30 days and then compound, and exactly, it's the same kind of compounding, and calculate the annualized interest rate. Okay, so you can actually match I have matched the calculation. So here I have matched so these are published um, from the website, but I have matched the calculation using the formula. So you can try that out. Okay, it's the same formula that we discussed. And here this plot shows you that the SOFR daily rates are not smooth. SOFR daily rates are not smooth. There are jumps. But obviously, if you take a moving average, they would be smooth. Okay. Now, these jumps have a very important implication in terms of how do we model the daily SOFR rates. That is the last topic for today. I will touch upon the model that CME uses to model the SOFR rates, daily SOFR rates, to calculate the term rates. Okay, so I'll show you that calculation at the end. So I hope this is clear. Let's see. Any questions? Let me know. If not, let's go back. Okay, so this is something that we just discussed. We talked about SOFR rates. You know about compounding, geometric mean, arithmetic mean, and how to calculate moving averages. Okay. All right. Similar for Easter, right? Easter is the risk-free rate for Euro. They also ECB publishes the daily Easter rates. They also publish the moving averages. Okay, so you can take a look at that. All right. Okay, so it looks like there is okay. So let's do this. Now this is the main area of confusion. Okay, so if you understand this, it will be easy for you to address the derivative valuations going forward. Let's understand this. So we discuss about term rate, right? Term rate is applicable for a certain maturity, not just overnight. 3-month rate, 6-month rate, 1-year rate, 2-year rate. How do we calculate this? First, understand one thing. So if we're talking about a rate between these two dates, T1 and T2, okay? And you are standing here right now. Both of these T1 and T2 are in future. That means it becomes a forward rate for you because you are here and the rate, the reference rate is applicable for a future period altogether. So this becomes a forward rate. If there is a coupon payment, floating coupon payment happening here, right? That will be based on this forward rate that you see from here, correct? And that forward rate that you use for coupon payment is always a simply compounded forward rate. Please remember, it is not continuous compounded. You calculate the simply compounded forward rate to calculate the coupon payment. Notional times year fraction times simply compounded forward rate. That's the formula for floating coupon. Okay. For the simply compounded forward rate, this is the formula. Okay, is the easiest formula. You can calculate this in n number of different ways, right? You can go to spot rates, then calculate the continuous compounded forward rate by using the formula R2T2 minus R1T1 by T2 minus T1. Then from continuous compounding, you have to convert to simply compounding. Avoid all this. Avoid all this. This is most efficient. The simply compounded forward rate is given as 1 divided by the year fraction between these two dates. Right? So let's say if it's a 3-month, then it will be 0.25 multiplied by first discount factor divided by last discount factor minus 1. Remember this formula. This is a very, very useful formula. I use it all the time. Okay. This avoids many different calculations to get this. First discounting factor, which is from T1 to T, that is this zero coupon bond, which is again the discount factor. Divide by second discount factor, which is T2 to T minus 1. So this formula will give you the simply compounded forward rate. If you have the yield curve available with you, then you have these discounting factors also available with you, right? So using that, you can calculate the forward rate, no issues. Then after some time, remember there is, so this particular floating coupon maybe, it could be a standalone FRA kind of deal, or it could be part of a big fixed floating swap where there are multiple floating payments. We're talking about one specific floating payment, which is about to happen here. Okay. In this case, it will be a forward starting swap. Anyways, yeah. After some time, when you reach here, that means the start of the rate coincides with where you are right now. Then this becomes a spot rate. This is the definition of spot rate, right? The starting period of the rate coincides with today or wherever you are. It becomes a spot rate. What is the simply compounded forward rate here? Again, use the same formula, no issues. Use the same formula. The only difference is this discount factor will get updated because from T2 to T is now T1. So you can easily figure this out from the yield curve that exists on this particular day, no issues. Numerator becomes 1 because it is a discounting between T1 to T, but now T1 and T are the same, one and the same. So there is no discounting. It's just discount factor becomes 1, right? So this is my floating payment. In LIBOR days, we could use this formula and just relax for the rest of the period. Relax in the sense we know exactly that this, whatever you found here as the floating rate, that is the floating coupon that you'll get. There is going to be no change to that in the interim. Okay. So you already know that this is the rate I'm going to get. End of story. Okay. But in case of SOFR, here is the complication. If it is a SOFR based derivative, the floating coupon here depends on the rate, obviously between T1 and T2, but that rate is a compounded rate of daily SOFR published between T1 to T2. So when you are in between T1 and T2, somewhere here, this is a very peculiar position. So at this point, you have partial fixings available to you. Whatever has happened before, between T1 to T, all the SOFR rates have been published. So these rates have been realized. The future SOFR rates are not realized. Okay. But if you have a rate curve, yield curve built for you, then you can figure out the rate between T2 T2. Let's say this is the whole period is 6 months and this is 3 months only. Okay. So you can figure out the 3-month rate from the yield curve. But for this 3 months before, right, it has to be based on the realized SOFR rates compounded over the 3-month period. Okay. So your forward rate is actually not forward anymore because you are already in between these two rates. This would never happen in case of LIBOR, right? If you are here, it does not affect the cash flow. It is already frozen. When you are in T1, that was already frozen. It would never change. But here, the floating coupon payment keeps getting updated as you move through time. Until you reach T2, it will keep getting updated. Okay, because it is the rate is based on the compounding of the daily published SOFR rates. So that's the thing. So what happens here? When you are here, partly the rates have been realized and partly they are unrealized. So this part can be figured out from the rate curve, 3-month rate, right? This part has to be compounded based on what has been realized so far or published so far. Okay. So if you look at this formula, same formula, it's very, very interesting. The first numerator, actually, let's talk about the denominator. The second discounting factor, which is between T2 to T, that remains the same. No issues. This discounting factor, T2 to T, remains the same. You can figure it out from your rate curve. The numerator, which was 1 when you are here, if you look at the original formula, it is the discounting factor from T1 to T, but now T is ahead of T1. So this discounting factor becomes a compounding factor. Okay, value of any cash flow, $1 cash flow, which is happening at T1, discounted to small time small t. That's the discounting factor, right? But now T is ahead of T1. So the numerator, instead of discounting from T1 to T, it becomes compounding. Okay, so and we know how to do compounding. We just talked about that, right? So geometric mean is the way using which you will calculate the rate between T1 to T. Okay, using the compounding. So I have written it in a continuous fashion. So if R is the short rate, continuous compounding, then you can just do integration of R from T1 to T. This will help us when we have a model for interest rate, like short rate models, then we can compute this integration. But forget about the integration. We don't need integration. Just the compounding factor that we calculated, right? Use that in the numerator. And that becomes your rate. Okay. And this will keep getting updated as you move through time until you reach T2. This rate keeps getting updated. So only when you reach T2, this rate will be fully known, not before that. I think it's a lot to take in. I'll pause here. Take a minute and try to digest this. And I'll show you a calculation in Excel just to reinforce what we are talking about. Let me know if any questions. All right, if no questions, let me show you the Excel example. It will make things even clearer. All right. So let's do this. So let's say you are here, 2nd April 2018, that is where you are standing right now, okay? There is a cash flow that is happening, floating rate cash flow happening after 6 months from here to here, 6 months. When you are here at T1, the floating rate based on which the coupon will be calculated is pure expectation. You haven't seen any SOFR published yet between this period, right? You are standing at T1, the entire rate can be derived from the yield curve. So whatever is your 6-month rate that you have constructed as part of your yield curve construction, take that and calculate the floating coupon. Okay, but that is not the final settlement. Okay, from a valuation perspective, you need to be able to project the floating cash flows and then discount them. Correct. So the forward rate can be easily calculated looking at the yield curve that you constructed on 4/2/2018. Okay, so if you're standing here on 4, let me zoom with this a little bit. Right. So on this day, that beginning, right, you have the yield curve constructed. These are my 3-month rate, 6-month rate, 0.751. The expected interest payment after 6 months would be just this one actually. If 1.55% is the spot rate for this next 6 months, that is what I'm expecting to get as part of the floating coupon payment. Correct. In LIBOR world, you look at this and you freeze this 1.55% and never ever change it. Right? That is what you used to do. Whatever is the prevailing 6-month rate, you freeze that. That will determine your floating coupon at the end of the period. In our case, 1.55%. No issues. Some time has passed. Okay, 3 months have passed. Okay, before that, there is a question. This yield curve is SOFR yield curve. Yes, it is the zero coupon rate curve constructed from liquid SOFR products. Okay, so that's the risk-free rate again. So there is no difference between SOFR and risk-free rate. That's the world we are going into. And good that you asked the question. So this is kind of like a blessing in disguise, I would say. Remember when we spoke about dual curve framework? LIBOR was used for forwarding, but OIS was used for discounting. But now we're again going back to the single curve framework with SOFR for everything, forwarding and discounting. Okay, so yeah, to answer your question, this is a zero rate curve that we create from SOFR products. So that is the risk-free rate. Okay. But these are term rates, mind you, because these are 3-month rate, 6-month rate, right? 1-year rate, etc., etc. How do we calculate the term rate? That's the last discussion topic. I will explain. It's the yield curve construction process. Again, you extract the rates, bootstrap the rates from liquid futures and swaps and create the curve. So this is important, okay? In the very beginning, at this point, what is the floating coupon payment? That is 1.55%. It's the 6-month rate. That's it. End of story. 3 months have passed. Now we are here. Okay, small t. You are standing here. I'm still dealing with this rate, T1 to T2. It is not done yet. That's the main thing. In case of LIBOR, right? Once you reach T1, you fully know this. There's no retro or anything, right? But in case of SOFR, I'm still figuring out how this rate would be. It's not, the story is not complete yet. But when you reach this, 3 months of daily SOFR rates have already been realized by that point. So the 6-month rate from T1 to T2, right, that defines my floating coupon payment is a hybrid of what has been realized and what is remaining. Okay. So it's simple. So now what you need to do is on this particular day, 7/2/2018, which is 3 months down the line, you have your new yield curve. Every day you are constructing the yield curve, correct? So on this day, you need to take the 3-month rate because that is the part that is remaining. From this day to 3-month rate would be this rate, correct? That needs to be sandwiched or clubbed with compounded rate that has been realized before over the last 3 months. Make sense? So the new 6-month rate that will determine my floating coupon payment rate is on 7/2, what is the 3-month rate that is for the remaining period, which is 1.39%. Compound that with whatever has been realized. Okay, so the realized part is available to you. So daily SOFR published rate, these are the SOFR rates. So from 4/2 all the way till 7/2, what are the daily SOFR rates that have been published? Take those, compound from here to here, T1 to T, and then from T to T2, take this rate, 1.39%, and come up with a final compounding element and then annualize it. Okay, so this is the calculation. See, shortcut calculation. So what I did is I used the index as a shortcut. The total compounding factor between over the last 3 months is simply the final index divided by the initial index. That's the growth factor. So look at this calculation. G73 is the final index. Divided by G8 is the first index. So that's the growth factor multiplied by this 1.39% rate for the next 3 months. So another compounding factor for the remaining period, which I'm taking from the rate curve. Okay. So G73 by G8 is whatever has been realized, and this is the unrealized. Compound everything together. This is the final compounding factor -1, annualize for 6 months. Now this is my new floating coupon interest rate. Every day you'll have an updated estimate of the floating coupon until you reach the final rate. Okay. Question from Arvind. K9 raised. Okay, these are simply compounded. You can see simple compounding, so you don't need that. If it is annual compounding, then you need to do 1 plus K9 to the power 0.25. Here it is all simple compounding, so simple interest. Makes sense? If you have continuous compounding, different formula, e to the power. So this is the main hurdle, right? If you cross this hurdle, then you are good. You can easily understand all the advanced stuff later on. I'll pause here. Any questions, guys? Okay, no questions. Awesome. Yeah, think about this a little bit. You should be able to get it. All right. So in the another next 15 minutes or so, let's do quickly look at the SOFR, some of the SOFR popular products. So starting with the SOFR futures, and then we'll briefly touch upon the yield curve construction, and then we can do question answer. Okay.